There are really three ways to get a series, a new series from a series that we know, or a function that we know. And they have to do with substituting and multiplying. They have to do with integrating and differentiating, and they have to do with working with a geometric series. And we've already looked at a couple of those, and we've taken terms from a series and we've integrated them, and we've taken terms from a series and we've differentiated them. But now we're going to work with some series we know, and we're going to do some substitution. So a known Maclaurin series, one that you should know or should commit to memory if you don't know, is e to the x. And these are the terms, the first few terms, and this is the general series. It's x to the nth power over n factorial. So to find the first four terms for e to the 3x, all we do is we substitute. Where there was an x, we make it a 3x. It was e to something, we put the something in place of the x. So the first four terms, we'd still have 1 plus 3x plus 3x squared over 2 factorial plus 3x cubed over 3 factorial. And that's it. We just substitute 3x in. Now, could you simplify it? Sure you could. 3x squared is 9x squared over 2 factorial. 3x cubed is 27x cubed. You could simplify this, but I'm not going to because I want to show how the general term finishes up, which, if all we did was substitute 3x in, well, that's all we do here as well. 3x raised to the nth power over n factorial. And that's it. All right, what if instead of substituting, right, instead of putting something in here in place of what used to be the variable, we instead took the old series and we multiplied it? Well, if I have if I multiply this by x squared, whatever I do to one side, I do to the other as well. So really, if I can just kind of put the example up here, if I multiply this by x squared, whatever I do to one side, I have to do to the other. So I multiply the other side by x squared. So the first term is x squared. The next term is x squared times x, which is x cubed. The next term, x squared times x squared, is x to the 4th. The next term, x squared times x cubed, is x to the 5th. And that's it. So the general term, you had a couple of ways you could do it. You could say, well, I had e to the x, and I multiplied it by x squared, and that would be fine. You could also write that that was x to the n plus 2 over n factorial, but you wouldn't necessarily have to. Okay? Next, what if I did both? Right? What if I multiplied and substituted? And these are really the two big things you can do. Yeah, you can do some division and things, but these are really easy to do because, as I said, if we do something to one side, we just do it to the other. So let's put in 5x and multiply each term by x. So the first term up here was 1. Well, there's nothing to substitute, but we are multiplying it by x. So x, like that. The next term would be 5x instead of x and multiplied by x. The next term would be 5x squared over 2 factorial, but multiplied by x. And the next term would be 5x cubed over 3 factorial and multiplied by x, like that. So again, we could clean this up quite a bit. We'd have x plus 5x squared plus, let's see, 25x squared times x, so 25x cubed over 2 factorial, plus 5 cubed, so 125x to the 4th over 3 factorial. Boom, boom, boom. Those are our terms. And our general, well, I would just go back to my original and say the general series, well, instead of x to the 5n, I had 5x. Or excuse me, x to the n, I had 5x to the n over n factorial, and then I multiplied everything by x. You could clean that up a little bit. You could have this be 5 to the n and x to the n plus 1 over n factorial, but again, you wouldn't necessarily need to. So we look for things that we can do with every single term. Now, let me pull one thing in here because this is a kind of common mistake. So why can't we use that same shortcut for e to the x plus 1? And I think we can catch it pretty quickly, okay? Let's say you thought, well, why can't I just substitute it, right? So it was, right? It was, first term was 1, that's easy, okay? So 1 plus, and then I substitute x plus 1, and then I substitute x plus 1 in here. Well, here's why this won't work. Because now it's not a Maclaurin series anymore. It's not about 0. It's not about x equals 0. This is about x equals 1. Negative 1. Okay? So we can't take a Maclaurin series, which is about x equals 0, and suddenly start using the same series when x is about a different number. And that's what we're doing right here. That's our mistake, is this x plus 1. Remember, that signifies the shift. That says we're around negative 1. So that's why this doesn't work. So you need to be careful of that. Substitutions like, 3x or x over 2 or x squared, anything up here like that doesn't shift us left or right. We can't allow ourselves to be shifted left or right because then it's not a Maclaurin series anymore. Okay, so look for those. Like this one right here, you would actually need to calculate derivatives. I wanted to show one more example. Okay, so find the first 4 terms and general term for this one. So 1 over 1 minus x. Please remember that this is the geometric series, right? First term and common ratio. And you'll see it right here. It's x to the nth power. And we start at 0, so anything to the 0 is 1. Please remember that. That is important. Okay? So the first 4 terms for this, well, you can see that 2 things have happened as we've worked from this series to this series. First of all, instead of x, we have 3x, and instead of a 1, we have an x squared. Well, let me rewrite this as x squared multiplied by 1 over 1 minus 3x. And again, you'll notice that I've done nothing that would shift left or right. All I've done is done a substitution of, instead of x, I have 3x, and I multiplied by x squared. But nothing that would move us to the left or right, so we wouldn't be able to use the Maclaurin series anymore. Okay, so the first term was 1. Well, 3x, that's not going to change that, but I am multiplying everything by x squared. So I'm going to have x squared as my first term. Then, instead of x, I'm going to have 3x. But remember, every term's being multiplied by an x squared. Then instead of x squared, I'm going to have 3x squared, and again multiplied by x squared. Instead of x cubed, I'm going to have 3x cubed, and then every term multiplied by x squared. You can clean this up if you'd like. I probably would. I'd have, x squared plus 3x cubed plus 9x to the 4th plus 27x to the 5th, like that. Those would be my terms. Now, my general term, if I go back up here, I think, well, every time I had an x, that I used to have an x, I made it a 3x. And then I took every single term and I multiplied it by x squared. You could clean this up a little if you wanted to. You could have 3 to the n and x to the n plus 2, but you wouldn't necessarily need to.